Chemistry is often described as the central science because it connects physics with other natural sciences, such as biology and geology. At its core, chemistry explores the substances of which matter is composed, investigates their properties and reactions, and uses these reactions to form new substances. Every time you cook, clean, or even breathe, you are participating in chemical reactions. Understanding chemistry starts with the basics: elements, compounds, and mixtures. Elements are the simplest forms of matter, like oxygen or gold, that cannot be broken down further. Compounds are substances formed when two or more elements chemically combine, such as water, H2O. Mixtures, on the other hand, involve the physical blending of two or more substances, like air, which can be separated into its original components. Chemical reactions involve the rearrangement of atoms to produce new substances. This process releases or absorbs energy, evident in everyday phenomena such as burning, rusting, and even digesting food. By studying these reactions, chemists can develop new materials, medicines, and energy solutions, making chemistry a continually evolving field that helps shape our future.
Organic chemistry is a fascinating branch of science that delves into the study of carbon-based compounds. These compounds form the foundation of life on Earth, making this field essential for understanding biological processes and developing new materials. In organic chemistry, we explore how atoms like carbon, hydrogen, oxygen, and nitrogen combine in countless ways to create everything from the DNA in our cells to the plastics we use every day. The versatility of carbon allows it to form stable, long chains and rings, which serve as the backbone for complex molecules. By mastering the principles of organic chemistry, scientists can invent new drugs, enhance food production, and even address environmental issues by designing biodegradable materials. This field is not just about memorizing structures and reactions, it's about discovering new ways to improve life through chemistry. Engaging with organic chemistry opens up a world of innovation and problem-solving opportunities.
Inorganic chemistry is a fascinating branch of chemistry that focuses on the properties and behaviors of inorganic compounds, which are compounds that don't primarily contain carbon. This field is essential because it lays the foundation for understanding how materials are made and how they can be altered to enhance their properties for various industrial applications. For instance, inorganic compounds play a crucial role in the development of catalysts that speed up chemical reactions in the manufacturing of plastics and fuels. They are also pivotal in the creation of ceramics, metals, and semiconductors, which are integral to the electronics industry. Moreover, inorganic chemistry is key to innovations in renewable energy sources, such as solar cells and batteries. By exploring the interactions and transformations of inorganic substances, scientists can design materials that lead to more efficient technologies, helping to revolutionize industries and contribute to a sustainable future.
Imagine you could speed up a reaction, like fast-forwarding a video, to see the results almost instantly. This is what catalysts do in the world of chemistry. Catalysts are substances that increase the rate of a chemical reaction without being consumed in the process. They work by providing an alternative pathway for the reaction that requires less energy. This is akin to lowering a hurdle, making it easier for the reactants to jump over and transform into products. Catalysts are pivotal in both nature and industry. For example, enzymes, which are biological catalysts, help our bodies break down food into energy quickly and efficiently. Industrially, catalysts are used to create everything from plastics to pharmaceuticals, making production faster, more efficient, and often more environmentally friendly. Understanding how catalysts work not only deepens our knowledge of chemistry but also equips us with tools to innovate and solve real-world problems, truly mastering the speed of science.
Redox reactions, short for reduction-oxidation reactions, are fundamental processes in chemistry where electrons are transferred between molecules, atoms, or ions. These reactions are crucial because they underpin various phenomena in both nature and technology. For instance, they are essential in how batteries generate electricity, how our bodies metabolize food, and even how metals corrode over time. In a redox reaction, one substance loses electrons, oxidation, while another gains electrons, reduction. It's an elegant dance of electron exchange that keeps the chemical world in balance. To identify which is which, remember the mnemonic oil rig: oxidation is loss, reduction is gain. Understanding redox reactions can also lead to insights into electrochemical cells, where chemical energy is converted into electrical energy, and vice versa. This conversion is pivotal in renewable energy technologies and various industrial processes. By mastering redox reactions, you unlock a deeper understanding of the world around you and the potential to innovate in countless ways.
Understanding pH is crucial for mastering the fundamentals of chemistry. pH, which stands for potential of hydrogen, measures the acidity or alkalinity of a solution on a scale from 0 to 14. Solutions with a pH less than 7 are acidic, while those with a pH greater than 7 are basic. A pH of 7 is considered neutral, typical of pure water. The pH scale is logarithmic, meaning each whole number change represents a tenfold increase or decrease in acidity. For example, a solution with a pH of 3 is 10 times more acidic than one with a pH of 4. This concept is vital in various scientific fields, from biology to environmental science, as it affects how substances interact and react with each other. By mastering pH, students can predict and control chemical reactions, making it a powerful tool in the arsenal of any budding chemist. Understanding this balance is not just academic, it's a practical skill that applies to everything from cooking to medicine.
Chemistry is often likened to an art form, where molecules are the canvas and reactions are the brushstrokes. At the heart of this scientific discipline is chemical synthesis, the process of creating complex substances from simpler ones. This transformative process not only fuels scientific inquiry but also drives innovation in industries like pharmaceuticals, materials science, and energy. Each reaction in a chemist's repertoire is a carefully choreographed dance of atoms. By understanding the fundamental principles of how atoms bond and interact, chemists can manipulate elements to form new, useful compounds. This manipulation is guided by the laws of thermodynamics and kinetics, ensuring that the reactions are not only possible but also efficient. Exploring chemical synthesis is like uncovering a hidden language of the universe. As we decode this language, we gain the power to solve real-world problems, from curing diseases to developing sustainable technologies. Thus, the beauty of chemical synthesis lies not only in its complexity and elegance, but also in its potential to improve human life.
Analytical chemistry is a fascinating field that delves into understanding the composition and properties of substances. Recently, technological innovations have revolutionized this field at a molecular level, allowing scientists to achieve more precise and faster results. Techniques like mass spectrometry and nuclear magnetic resonance (NMR) spectroscopy have been enhanced by digital advancements, enabling chemists to observe molecular interactions in real time. These tools can now identify the structure of complex molecules quickly, which is crucial in drug development and environmental monitoring. Additionally, the advent of microfluidics has miniaturized experiments that once required large amounts of chemicals and space, reducing waste and costs. Such innovations not only advance scientific knowledge, but also have practical applications in medicine, manufacturing, and beyond. As we continue to develop and refine these technologies, the potential for new discoveries and improvements in various industries seems limitless. Colloid science and nanotechnology are fascinating branches of chemistry that explore materials on an incredibly small scale. Colloids are mixtures where one substance is dispersed evenly throughout another, like milk or fog. These are not just scientific curiosities. They are central to many products we use daily, from cosmetics to paints. Nanotechnology takes this a step further by manipulating matter at the nanometer scale, which is about 1/80,000th the width of a human hair. This manipulation gives materials new properties that can be revolutionary. For example, nanoparticles can make materials lighter yet stronger, or enable drugs to be delivered directly to targeted cells in the body. As we continue to understand and innovate in these fields, the potential for new and improved materials is vast, impacting everything from medicine to electronics, and even environmental protection. This is why colloid science and nanotechnology are key to shaping the future of everyday materials.
Crystals are not just eye-catching objects, they are a fascinating intersection of art and science. At their core, crystals are solid materials whose components, such as atoms, ions, and molecules, are arranged in a highly ordered microscopic structure, forming a crystal lattice that extends in all directions. This structure is what gives crystals their characteristic shapes and unique properties. The process of crystal formation, or crystallization, can occur naturally, such as in the formation of snowflakes or gemstones, or artificially in laboratories. Chemists study this process to understand how the conditions under which crystals form influence their properties, such as hardness, melting point, and their ability to conduct electricity or heat. Moreover, crystals are not just subjects of scientific study, they are also crucial in various applications. They are integral in the manufacturing of electronic components, pharmaceuticals, and even in everyday products like cosmetics and paints. By exploring the chemistry of crystals, scientists can innovate and improve these applications, making crystals essential not only for their beauty but also for their utility in modern technology.
Chemistry is a fascinating journey into the building blocks of our universe. At its core, it involves the study of substances, what they are made of, how they interact, and the roles they play in our daily lives. One of the most intriguing aspects of chemistry is the discovery and naming of compounds. This process is not just about assigning names, but about uncovering the hidden stories and patterns in nature. Each compound's name serves as a clue to its chemical structure, properties, and history. For instance, water, known chemically as H2O, indicates 2 hydrogen atoms bonded to 1 oxygen atom. The naming of compounds follows specific rules set by the International Union of Pure and Applied Chemistry, IUPAC, ensuring that each name provides clear and universal information about the compound's makeup. Understanding these names can feel like deciphering a code, revealing insights into the vast and intricate world of chemistry. This knowledge not only enriches our understanding of the natural world but also enhances our ability to innovate and solve problems across various fields.
Welcome to the fascinating world of chemistry, where the periodic table is not just a chart but a powerful tool that unlocks the mysteries of elements and their interactions. This table, organized by atomic number, electron configurations, and recurring chemical properties, serves as a roadmap for understanding everything from the air we breathe to the metals that power our technology. Each of the 118 elements has a unique story and a specific place in this table, grouped into categories like metals, nonmetals, and noble gases. By exploring the periodic table, we can predict how these elements react chemically, their state at room temperature, and even their potential uses in everyday life. This predictive power not only enhances our knowledge of material properties but also drives innovation in fields such as medicine, energy, and materials science. Dive into the periodic table, and you'll discover a world where elements reveal their secrets, allowing us to solve complex problems and create new possibilities for the future.
Polymers, the giants among molecules, are long chains of repeating units that have revolutionized our world in the form of plastics, rubbers, and fibers. The journey into the world of polymers began with the work of early pioneers like Hermann Staudinger, a chemist who first proposed that polymers were long chains of atoms linked by covalent bonds, a theory for which he won the Nobel Prize in 1953. Following Staudinger, Wallace Carothers made groundbreaking contributions by inventing nylon, the first true synthetic fiber, which transformed the textile industry. Another significant figure, Stephanie Kwolek, developed Kevlar, a polymer 5 times stronger than steel, widely used in bulletproof vests. These trailblazers not only advanced the chemistry of polymers but also paved the way for innovations that have provided solutions to many modern engineering challenges, making our lives safer, more comfortable, and more efficient. Their legacy is a testament to the profound impact that dedicated scientists can have on technology and society.
Environmental chemistry is a fascinating branch of science that explores the chemical processes occurring in the environment and their effects on human health and ecosystems. This field plays a crucial role in understanding pollution, a major environmental issue, by studying the chemical nature and reactions of pollutants. These pollutants can be anything from industrial waste to car emissions, and they impact air, water, and soil quality. Environmental chemists also develop methods to detect and measure pollutants, providing essential data for creating strategies to control or eliminate harmful substances. Another significant aspect of environmental chemistry is the study of purification processes, such as water treatment and air purification, which help remove contaminants and restore the natural balance of the environment. By delving into these topics, environmental chemistry not only helps us comprehend the complexities of pollution but also equips us with the knowledge to combat environmental challenges effectively.
Biochemistry is the fascinating science that explores the chemical processes within and related to living organisms. It's a discipline that bridges biology and chemistry by studying the molecules that make up cells and tissues and how they interact to function. At the heart of biochemistry are proteins, enzymes, carbohydrates, lipids, and nucleic acids. Each of these molecules plays a critical role in vital processes such as metabolism, which includes all the chemical reactions that produce energy and build new cells. Biochemists also study how cells communicate with each other during growth or fighting illness. By understanding these processes, biochemistry aims to solve biological problems and has applications in areas like medicine, agriculture, and environmental science. For instance, biochemists work to develop new medicines, improve crop yields, and even in the production of biofuels. Thus, biochemistry not only helps us understand the essence of life but also equips us to enhance it.